Hello and welcome to another LeetCode video. Today we're going to be doing problem number 1472, design browser history. It's a pretty interesting problem because it mimics how your browser would work when you visit pages, and so you might have something that you have to do similar to this at your actual job. And so you have a browser of one tab where you start at the home page and you can visit another URL, go back in the history number of steps, or move forward number of steps. Implement the class, initialize the object with a home page, visit URL, clears up all forward history, move back. You can only go X steps. So if steps is greater, you can only go back X. Return the current URL after moving back in history at most steps. Forward, you can move forward, you can only move X steps forward. And return the URL after forwarding in history in most steps. So let's actually show our URL, and we're actually going to be doing this with a linked list, and I will show you why. Because it's going to be kind of easy to go backwards and forwards and clear things up. So let's show you how that looks like. So let's take a look at this example. So we make a new browser history, LeetCode.com. I'm just going to represent that with an L. So we are at LeetCode. Okay. We are going to create a node. Then we visit Google. So by visiting, it means we can just make another node. Let's call that G. And then we are going to be, so we were here, now we're here. Okay. Then we visit Facebook. So let's just make another node. Let's go over here, F. Now we are here. Okay. And now we want to visit YouTube. So let's make another node, Y. Okay. Now we want to go back. So we are here. Now we need to go back. And by the way, this is going to be a doubly linked list. It's going to be a nice thing about that. So we're going to easily be able to go forward and backward. So we are here. We need to go back. So we are now over here. And it's going to, print facebook.com. And we want to go back again. So we are here. And it's going to print google.com. And then we want to go forward one. So we would go over here, forward. Fine. Now we want to visit linkedin.com. And so if we're here and we visit, so the way it works is if you're at a page and you go back and you visit another page, you clear up your forward history. So if we are at Facebook here and we try to visit LinkedIn, the forward history gets cleared up. And it's going to be really nice with a linked list to clear up the forward history because we can just say the next node of the current node we're at is just null. So we have an easy clear as opposed to with an array where we have to delete half the array or something, And so now we're going to make a LinkedIn. So we'll just call that L. I'm going to go over here, make a new node. Now we are over here. Let's delete this. And then we want to go forward, but we cannot. So now we want to go back twice. Okay, pretty straightforward. And all these back and forward iterations are pretty straightforward. So we want to go back twice, so we're going to go over here now. And then, let's see here. Browser history back 7. Okay, so we can only actually move back 1, so then we come back to LeetCode. Print LeetCode. So let's actually talk about the code for all these functions, including init, visit, back, and forward, and how it's going to work. Okay, so init. Pretty straightforward. We're just going to make one node, and it's going to be whatever our home page is. Let's just call that H. So node H. Then when we visit, whatever node we were at, let's call that visit. Whatever node we are at, let's say we're at this H, it's pretty straightforward. When we visit, we just say, okay, the new forward node of whatever node we're at is the node we're visiting. So let's just call whatever the new node we're visiting V. So we have some history of H, but the stuff that's forward, let's say we did have some nodes here, 1, 2, whatever. And so there was a forward history. Whenever we visit, we just clear up the forward history. And we make a new node in front, and then we traverse to that node. Okay, so that's going to be then forward. Also pretty straightforward. We just traverse down the node, so we just keep going forward. And then whenever we can't go any more forward, so for example, we're at this node, let's say LinkedIn. This LinkedIn doesn't have a forward. So then what we would do is we would just return. So we keep trying to go like whatever we kind of go like the max of steps or no more nodes. And whatever runs out first, that's when we return. If either we go the amount of steps or we just have no more forward nodes. And backward is going to be the same thing. I'll just symbolize it by B. So this is the same thing, max, steps, and then number of nodes. So that's why a linked list is really nice, because we can traverse really easily, and we're going to be implementing this as efficiently as we can. Like the only more efficient thing would be like if we, so the problem with this kind of algorithm is when we move forward and backward, we have to, we do have to like go one node at a time, which is kind of annoying. But other than that, we're pretty much doing the best way we can. And if we had an array, like if we did have an array that had some nodes, like 0, 1, 2, 3, whatever, the problem with having an array is like, let's say we're at this node and we want to clear the forward history. Well, now we have to like delete all of this. And then we would have to like add more nodes here and stuff. So that would be like kind of annoying. And so that's why it's a little bit cleaner with the linked list. Our traversals aren't that bad. They're still going to be big O of n, where yeah, as opposed to with an array, you would be able to have a big O of 1 traversal forward and backward. But like I said, with an array, the clearing up things is going to be a lot more annoying. So there's kind of like benefits and losses to everything there. So, and plus, you know, linked list, you get to practice your linked list. Pretty good. So let's do that. So we are going to make a linked list class here. So, or actually make a list node class, right? And then we're going to have a constructor. You're going to have, oops. Okay, so we're going to have a forward node and a backward node, and these are going to be the pointers. And we also do want to have a value, right? So val, and we can have some default. We are always going to pass in a value, but then for forward and backward, we can initialize them to none if we, if we don't pass in anything. Okay. And then this is just going to be self.val equals val, self.forward equals forward, self.backward. Okay. Now we are going to do the init. So the init, once again, it's going to take a string. So we're just going to create a new node here. So we're going to say self.curNode, let's say, equals, and then it's going to be a list node with a value of homepage. And it's not going to have a forward or a backward. Okay. So now remember when we visit, pretty straightforward. We just take the current node we have and then we create a new node and we have that node point to it. So like if we're at some node here, then we are going to just move up a node. So we are going to, if we're at this node, we're going to create a new node. We're going to put in the value and then we're going to traverse over here. So let's do that. So we can just make a new node like a forward node or something equals list node. It's going to take the URL and the forward will be none. That's going to be none. And the backward node will be the current node. Okay, and now we have to connect them. So it's going to be self.curNode.forward equals forward node. Okay, and now we just have to move the current node up. So self.curNode equals forward node. Okay, so that's going to be a visit. Now for back, remember we're going to try to go back as much as we can, but we're going to go back as much as we can until we either run out of steps or we run out of nodes. So while steps and self.curNode.next, it's not equals none. Or it's not going to be next here. It's going to be backward. It's not equal none. Okay, there we go there. So we are going to go back. So self.curNode equals self.curNode.backward. And then we are going to decrement from steps. Okay. And so that's all we need to do there. So like if we have to do one step, we would go one step, then this would be decremented, then this would be return. So we can just return here, self.cur node. And then forward is literally the same thing, except we just go forward. So forward. And that's going to be the same, that's going to be the same. Okay, let's see if we screw anything up. Right, so this needs to be... Okay. Line 56. Oh, so we need to return a string. Okay, so this is just going to be val, nothing and nothing. Okay, nice. I don't really care about that. No, thank you. Okay, so let's talk about the time and space complexity. So for the time, let's just, once again, for these design classes, let's go over every single function. So for init is big O of 1. For visit, it's going to be, so we can write this. So init, big O of 1, visit, big O of 1, and then what do we have? Back is big O of n would be worst case, where n is the number of nodes that are currently in our browser. Does that say URL link 20? Yeah, so it'd technically be like 100, which would be big O of 1 actually, because that's just a constant number. And then forward big O of 1, because we can only take 100 steps maximum, so that's not super bad. Like something worse would be, imagine you do use an array, and then you just keep making the array bigger. So let's say your array has like 2,000, 3,000, 4,000 elements, and then you have to delete like the whole thing. That's gonna be more expensive than these forwards and backs. Okay. Yeah. So that's all for that. Now let's look at the space complexity. And once again, so for this we don't have to do it for every single function, but it's going to be big O of worst case scenario. Our space is going to be, if there's 5,000 calls, it's going to be big O 5,000 pretty much, where we're just, like, let's say we just keep visiting over and over and over. Every single call is a visit, let's say. That would be worst case, I think. Homepage length. So this is just a string. This is a string. Yeah, and then as far as like, if you want to figure out, yeah, I mean, these are just constants, so it's not going to matter. Like if you're counting how many letters you're storing, they're only 20 letters a word, so it doesn't really matter. Yeah, so the worst case scenario is big O 5,000, where every single call is just like a visit where you keep adding to the linked list. All right, so that's all for this problem. Hopefully you liked it, and if you did, please like the video and subscribe to the channel. Thanks for watching, and I'll see you in the next video. Bye.